Good evening. Happy Thursday. Uh, we're gonna get back to mathematics. I'm sorry about bad hair day, but I just left it like this because it kind of look funny. So, and I love entertaining people, so let them laugh. Anyways, we get back to mathematics. Okay, so in like 10 minutes, but we're gonna talk about something else too. But so basically, uh, what's that? The approach we are taking to solve Goldbach's conjecture problem is characterize Goldbach's conjecture problem as combinatorial problem, counting. Okay, so how many ways are there? So we want to come up with Goldbach's counting function, meaning how many ways are there to express an even integer as summation of two odd primes. Okay, so that's counting problem, and if we cannot find closed form formula, that's fine too. Okay, maybe finding a recurrence formula is enough. And we already kind of have recurrence formula between a composite counting function and prime counting function, right? So yeah, so we're building some foundation, okay, and a couple of days ago we found the partition function recurrence formula, right? Closed form formula, I don't think it's necessary to find closed form formula, okay? Even if we all we have is just recurrence formula, maybe it's good enough for us to prove something, you know? So, so, uh, so we found some partition function recurrence formula, right? Yeah, so we're gonna move on. Now, next step is to find some kind of recurrence formula for product partition function. What is it? In additive partition function is this, okay? Given number n, how many ways are there to express n in terms of summation of smaller numbers, right? And in our product partition function, it's similar, but we don't use addition, we use multiplication. Given a number n, how many ways are there to express this number n in terms of or in terms of small product of smaller numbers? Okay, and to simplify, what we focus on now is to use only pure composite numbers, meaning when you do prime factorization, prime factors do not repeat themselves. Okay, so yeah, you remember Möbius-Legendre formula? They kind of deal with that, the repetition of primes in the prime factorization, something like that, right? Something like that, some repetition of primes. Yeah, I remember seeing that. All right, the Möbius-Legendre formula has to do with recurrence relationship or counting function, prime counting function. Okay, so but that's not what we do here. Okay, just FYI, there's some similarity of what we do here and what Möbius and Legendre did. I just want to point out the similarity because what we do here is not from their formula. Okay, I later learned about their formula just a little bit, but I don't quite fully understand because I didn't study Möbius-Legendre formula. Okay, because to me it's not quite obvious what they did. All right, and I don't really want to study what they did either. I don't have time. All right, we do our own things here. Okay, we are too busy. All right, so of course the way we approach prime number problems like Goldbach's conjecture is very non-mainstream. Okay, so mainstream mathematicians, majoritarian people, they don't take approach like we do. Okay, what they do use is like integration, like calculus, right? That's what they do, and like the Euler Riemann zeta function, like all this polynomial or whatever. Okay, that's not the kind of approach we are taking. Okay, like Riemann hypothesis, whatnot. We don't do that. Why? I don't have time to learn what they do. Okay, what they did. So we do our own things here. Okay. Now, let's talk about something else, and we get back to that. Okay, mathematics. Okay. Uh, there are two ladies, Ellen DeGeneres and Rachel Maddow. They're both very money, power, fame, very rich, very famous celebrities, right? And Ellen DeGeneres, I don't know why she's so famous. I guess a lot of people like, a lot of people, I guess, enough number of people think she's funny, but I don't think she's funny at all. And I just don't see why she's celebrity, okay? Other than she's just LGBT member, okay? Rachel Maddow, I think she has very good sense of humor, okay? But both of them, Ellen DeGeneres, Rachel Maddow, they're LGBT members and they are rich. So through the operation of romance market, they attract the most desired women in romance market in America. Yeah, young, slender, blonde. Those are the typical trophy wife, right? The prize girlfriend. Yeah, young, slender, and blonde, Caucasian. Slender, right? And they got them, right? Ellen DeGeneres, Rachel Maddow, because they are rich, right? So yeah, it's romance market. That's how it works, right? And I kind of feel bad because those beautiful, I mean, Ellen DeGeneres and Rachel Maddow, they're not very attractive, right? They're like have short hair. They're not quite feminine, right? But I guess they work very hard and very ambitious, so that's why they got where they got. Celebrity rise to the fame, right? But they're not attractive people because they wear this, have this very masculine. As a female, they have masculine style, like short hair and the way they talk and walk, very masculine. So that's not attractive to us guys, right? But their female spouses, they are very, very attractive. Females, very feminine, right? So I feel bad because when these two women marry, then this attractive female's gene does not get passed to the next generation. I mean, lesbian couples sometimes they have some artificial insemination and they have babies, and but it's not the same, right? It's not the same as having a mother and father. So it's not as good. That would be my guess, right? And let's the gay marriage, okay, they don't last very long because it's counter to our human nature, all right? So like easy come easy go kind of, you know, yeah. So yeah, I don't like seeing what they do. What a waste of these beautiful women's genes. So hopefully they divorce, and one of them divorced, like Ellen DeGeneres and the other girl, the beautiful girl, Portia or something. They divorced, right? Good, great, that's great. Yeah, because it's not supposed to work, alright? So Rachel Maddow and her wife, hopefully they divorce very soon, so that the pretty girl get a lot of money and get a man, good man of his her own race, and then so that she have some children, you know, so that her children have mother and father of the same race, opposite gender. Okay, that's what we recommend. Okay, so all right, let's take a break and then let's get back to mathematics. Okay, so 9 minutes, 10 minutes has passed. We have 5 more minutes before break. Okay, so some people think I'm gay. Some people think I'm gay. Maybe my hairdo kind of look like drag queen style, like transvestite, like transgender. Maybe some people like think I'm some kind of drag queen. The thing is this: you don't have to be an LGBT member to have your own style. If you're male, you don't have to be LGBT member to dress up nicely and to be fashionable and to experiment with your hairdo. You don't have to subscribe to LGBT member to do that. If you're female, you don't have to subscribe to LGBT group in order to be as strong as a man, as strong like a man, as strong as a man. Okay, it's unnecessary. You can be straight and female and be very strong person. Likewise, you can be straight man and be very beautiful man. You don't have to. It's not necessary that you subscribe to LGBT group. That's not necessary. Okay, so I am straight. I wish I had a girlfriend, but so how come I don't have any girlfriend? Well, first of all, I used to date, but I'm running for Alaska State Senate. I'm running for president, so and I do not want to get married, but marriage is what women want. So what end up happening? Break up, and women don't appreciate that. So that's why I'm single. But I do want to have a girlfriend. But I don't want to get married. I don't have kids. I just want to date. And I don't want to date young women because I don't want to waste their time because they need to get married and have kids, young girls. So mature ladies, well, there are not many of them who are single. So that's why I'm single. Okay. So, but I do want to have a girlfriend. Okay. So, but even if I don't have a girlfriend, I'm fine. I do mathematics, and to me that humanology, economics, physics, yeah, that's to me that's good enough. All right, we'll take 5 minutes. Okay, so okay, okay. All right. Okay, let's grab an eraser and get back to mathematics, shall we? You don't need that many pens here, so just one holder, pen holder is enough. Okay, let's do this, shall we? ah. Mathematics, never-ending story, right? There's this children's movie called Never-Ending Story. Not a huge fan. That movie, I quite like the style. Okay. Yeah. Doesn't quite look fresh, you know, the kind of like all the puppetry that they did. It doesn't look very fresh. And also like children's puppet show like Sesame Street, not a huge fan. They don't look fresh. Okay, they look kind of artificial and perhaps polluted. Uh, Not a huge fan. Anyways, so 2310. Okay, can you read? Yeah, faintly, right? Yeah, good enough. So this number, let me grab some wine, okay? So not quite ready for vodka yet. But I drink so. It's a pure composite, okay? So, um, talking about composites, I read a science article, news article today. What's in there? I gotta take it out, okay? I don't know what that is, but give me a second. Okay. I use my chopsticks to get that thing out. I don't know what that is. I'm very picky about my drink, okay? So, although I never wash my glasses. That's good. Yeah, I read a science news article today during my breaks, and then so in animal species, hybridization is not always healthy thing. Okay, like you hybrid horse and donkey, you as a result you beget mule, but mule is uh, barren. Mules cannot reproduce. Okay, so yeah, it's not also in the fish species. Sometimes mixing two different species in the fish, it the next generation have some genetic defect as a result. Like it causes melanoma, cancer. Okay, so yeah, hybridization isn't always healthy thing. Okay, so just want you to know. Okay, because I just learned. Okay, I of course I learned about mule being barren long time ago, but just FYI. Okay, all right. Now these are pure composites, okay? Because when you count the prime factorization, the primes doesn't like repeat itself. None of them. All right. So We call it pure composites. Okay? For now, because otherwise it's more difficult. We'll do it later. All right? Now, we can group this the grouping here is this, all right? Express this number 2310 in terms of product of two numbers. Okay? And because there are 5 primes in this prime factorization, it boils down to additive partition problem. All right? 5 is equal to 1 plus 4, 2 plus 3. One plus 4, 2 plus 3. That's like express 5 in terms of addition of two numbers, right? Right? And there are two possibilities, right? So, because this guy is broken down to what? P3, using our formula, P3, 1 plus P3, 2. Which is equal to 1 plus, so this becomes P1, 1. So that's 2, right? So yeah, the 2 has to do is 1 plus 4 or 2 plus 3. Okay, so these are the number of categories. Okay, and given inside of one category, then there's some variation. What is that? We have to think about it. Okay, so but yeah, this P52, it gives us the number of categories. Okay, and here you have I mean, you can quite read it as well, right? So I just write in a thicker pen. There we go. Up here we have P51. Okay, so and now, so that's the second group, that's the first group, right? I mean, third group, P53. Okay? That's the number of subcategories, okay? Number of categories given in a group. Alright, so this gunk. Express 5 in terms of addition of 3 numbers, okay? 1 plus 2 plus 2, 1 plus 1 plus 3. I guess that's it. So P53 is equal to P21 plus P22, which is 2, okay? Now, here, you express 5 in terms of addition of 4 numbers. That's P1, 1. So that's 1. Okay. 1 plus 1 plus 1 plus 2. Okay. And here we have express 5 in terms of addition of 5 numbers. So 1, right? So, okay. So it gives you the number of subcategories. Okay. So you have 1 plus 2 plus 2, and then 1 plus 1 plus 3. Two categories. Here you have 1 plus 1, 1 plus 4 or 2 plus 3. Okay, so that's why you have two subcategories. Okay, okay, so that's the relationship between multiplicative partition set and additive partition set. Okay, so very good. Now, given subcategory, how do we count that? It has to do with combination, I think. And let's take a look at it. Okay. All right. It is, at least in these two instances. Okay. Here you have 5C1, right? 5C1, and here you have 5C2, right? Yeah, 25 of them, right? I mean, 10 of them. Okay. Sorry. Okay. And here the picture is a little bit more complicated. Okay. I guess I made some omission here. All right. Because there are more than this. You have two times three times 7 times 5 times 11. Okay. Here you have 3 times 2 times 7 times 5 times 11. Here 5 times 2 times 7 times 3 times 11. Here you have 7 2 times 11 times 3 times 5. Here you have 11 times 2 times 5 times 3 times 7. There we go. Yeah, we somehow omitted that. Most likely out because I was very drunk. Okay, so. Hey. Oops, we have some more. Well, let's write it out. Two times. Why is this so light? My goodness. 3 times 11. 5 times 7. Here you have 3 times. 2 times 11. 5 times 7. Here you have 2 times 11. 3 times 7. 7 times. 2 times 5. 3 times 11. 11 times. 2 times 7. 3 times 5. Okay. Whew. Ugh. Is it time to take a break yet? It's a combinatorial problem. So what we have here is, let's see. Okay. Yeah, good old days. Okay, when I was in middle school in South Korea, we started learning about combinatorics as a preliminary to learn probability and then statistics. Okay, so combinatorics, probability theory, and then statistics. Okay, so I was in middle school. Okay, my siblings taught me this, and along with my teachers. Okay, so yeah. Because when I was learning in Korean public middle school, that wasn't good enough. Okay, so I enlisted assistance of my siblings who are older than me, and they taught me. Okay. So it goes like this. Okay, we're gonna take break very soon. Okay, so this guy, okay, is out of 5, you choose one combinatorial fashion and multiply by. So it's called something like your balls, your black box. You have 5 balls. Okay, you pick one ball, and you don't put it back. You pick one ball, and you pick the next ball. Okay, so it's like counting is a combination without replacement. Okay, that's what it calls. Something like that. Okay, so now out of 4, you pick 4, which is 1. Okay, so that's why it's 5. Here you have out of 5 you pick 2, multiply by then 3 is left, right? Out of 3 you pick 3. Okay, here what you have is out of 5 you pick 1. Now you have 4 left, right? Out of 4 you pick 2, and then you have only 2 left. So 3 are gone. Out of 2 you pick 2. Okay, so there we go. Yeah, now we know what this is. Now let's take a break. Okay, so very good. Well, one more. These guys, out of 5 you pick 1. Now 4 left. Out of 4 you pick 1. Now 3 left. Out of 3 you pick 3. So that's what it is. So there are 20 of this. Okay, I think maybe we should divide by 2. Okay, why? Because multiplication is commutative. That's why. We'll come up with a general formula. Okay, yeah. So there are 30 of this. Let me see. So here you also need to divide by 2. Okay, okay. Hmm. Why divide by 2? Because you have composite number of 2 primes, right? So that's why they're kind of symmetric, okay? So, and here you have 2 primes, and yeah, it can be counted. Yeah, now I see what's going on. Okay, very good. I know exactly what's going on here. Okay, so here, let's just do one more. Okay, so out of 3, out of 5, you pick 1. Out of 4, you pick 1. Out of 3, you pick 1. And then out of 2, you pick 2. And probably you divide by 6, which is 3 factorial. Why? Because you have 1 prime, 1 prime, 1 prime, right? So yeah, ordering doesn't matter. So okay, so that's 3 factorial. Okay, okay. It's number of repetition. Okay, oh, the prime number. Okay, okay, I got it. So let's see. 10 of them? Yes. Okay, we found general formula. All right, so very good. Let's take a break. Okay, I break this down for you. Okay, you grab the whiteboard. All right. So, okay, very good. We got it. Okay, so let's take a break. Okay, so one more thing. One more thing. Okay. All right. Oh. Hmm. Let's take 5 minutes or 10 minutes. Oh. Uh, is this pen bad? It's not too bad. Okay. So we got it. All right, we got it. You just need to spell it out. Grab a new whiteboard and spell it out. And our partition recurrence formula that we found, all right, it has direct application right here. Okay. So it's a very good formula, very useful. Okay, we found application right away. Okay, good. I'm glad, very grateful to our God for inspiration, guidance. Jesus said, "Wind blows." That's how Holy Spirit works. That's how it got us today, right? We didn't plan on this. Somehow we were led to be here. Good discovery. Guidance by Holy Spirit. Okay, so yeah, yeah. We thank God, thank Jesus. Yeah, yeah. So let me explain it to you before we grab a new whiteboard. Okay. We have five prime factors that whose product is 2,310. Right? Now, we want to count the number of ways to express. You know what? My hair is so distracting because when I'm filming this, I get to see myself on this laptop screen, and it's very distracting. This hair sticking out. It's so distracting. Better, less distracting now. So, we gotta focus, okay? We cannot afford to be distracted by my rambunctious hairstyle, hairdo, coiffure. I hope I didn't distract my coworkers too much, okay? Because mostly I work by myself, okay? So, yeah. Yeah. Now, we are counting the number of ways. Man, this sticking out again. We're counting the number of ways to express 2310 in terms of products of smaller numbers. We call it multiplicative partition set or multiplicative partition function. Okay? We call it mu of n, okay? Mu for multiplicative. And we'll come up with a formula for it because we already know what it is. We need to just spell it out, right? So the logic is this. Logic behind multiplicative partition function is we categorize them, right? Yeah, restrictive partition concept, right? So how many ways are there to express 2010 in terms of multiplication of one number? That's just itself, right? Yeah. this guy is nothing but out of 5, just choose 5, okay? So, okay? Yeah. Next, how many ways are there to express 2310 in terms of multiplication of two numbers? Okay? Alright. There are two subcategories, okay? One number containing only one prime number, and the second number containing 4 primes. So that's first category. Second category, subcategory. First number contains 2 primes. Second number contains 3 primes. Okay? And that's that. The third big category, major category, is this. Express 2310 in terms of product of 3 numbers. Now, there's 2 subcategories, 2 minor categories. That's this, okay? First number have 1 prime, second number have 2 primes, third number has 2 primes. So that's 1, 2, 2. Okay? That's first subcategory. Second subcategory is this. First number has 1 prime, second number has 1 prime, and third number has 3 primes in there. 1 plus 1 plus 3. Okay? Fourth category. Express 2310 in terms of product of 4 numbers. There's only one subcategory. First number has 1 prime, second number has 1 prime, third number has 1 prime, and fourth number has 2 primes. That's it. Okay. Fifth category also has one subcategory. Express 2310 in terms of product of 5 numbers. Yeah, they're all, each of them all primes. Okay, that's it. You got it? Okay. It helps me to explain to you because it's kind of organized what we have here, right? It's a nice review. Teaching helps, okay? Because when you teach, you kind of organize in your head, right? Teaching helps, okay? All right. Now, for each subcategory, we can come up with a formula. All right. So, first one is just out of 5, you pick 5, right? But so that's first categories. Second category and first subcategory, out of 5 primes, pick 1, 5C1, okay? And what's left? You have 4 left. Out of 4, you pick all 4, okay? And you multiply them, all right? So that's why you have 5 of them, okay? Now, yeah, I'm sorry, it's such a mess, okay? The second category and second subcategory, the formula for it, out of 5, you pick you pick 2, 5C2, okay? Out of 5 primes, you pick 2 primes, and so you have 3 primes left that you didn't choose. Out of 3, you pick all 3, okay? So that's like 10 of them, right? So that's why you have 10 of them, okay? I explain all this to you, then we'll take a break, okay? So there's a lot. But we'll have only one formula to explain all this. Alright? one formula explaining everything here. Okay, so and we're gonna generalize even further. All right, so. Okay. Category number 3, we have two subcategories, okay? This is the formula for it. Fourth subcategory, okay? So out of 5, you pick 1 prime. Now, 4 of them left. Out of 4, you pick 2 primes, and then you have 2 left. Out of 2, you pick the rest of them, 2, okay? And you have to divide by 2 because, actually it's 2 factorial, okay? Because you have 2 numbers. First number has only 1 prime. But both second and third numbers, each of them have 2 primes, okay? And you can commute them because multiplication is commutative operator, okay? Ordering doesn't matter, okay? That's why you divide by 2 factorial, okay? Right. Whew. Second, you have out of 5 you pick 1, out of 4 you pick 1, out of 3 you pick 3, right? Divide by 2 factorial because you have 2 numbers that each of which has only 1 prime, so it's the same length, same width, right? In terms of prime factorization, okay? We have to define a function, something like prime counting function, okay? So given a factorization of a number, how many different primes are there, okay? So yeah, we just call it pi, okay? So yeah, because the first and second number, they only involve 1 prime, okay? That's why you divide by 2, because multiplication is commutative, okay? Now, fourth category, okay? You out of 5 you pick 1, out of 4 you pick 1, out of 3 you pick 1, out of 2 you pick 2, okay? So 1 plus 1 plus 1 plus 2, okay? So and there are 3 of them with the same length. 3 numbers, each of which has only 1 prime, right? So that's why you have to divide by 3 factorial, 6. Okay? Alright. And the number matches, okay? There are 10 of these. Yeah. Here, you out of 5 you pick 1, out of 4 you pick 1, out of 3 you pick 1, out of 2 you pick 1, out of 1 you pick 1, and then because there are 5 numbers, each of which has only 1 prime, so each numbers have exactly the same number of primes, right? That's why you have to divide by 5 factorial, okay? And yeah, 5 factorial divided by 5 factorial 1, okay? So that's how we got this, okay? Now, we're going to take 5 to 10 minutes break, and then we'll generalize this and come up with a nice formula, okay? We'll grab another whiteboard, okay? So yeah, we got it. This is like high school, middle school, first more advanced AP credit, okay? But maybe undergrad level introductory combinatorics problem, okay? Yeah. Like freshman, sophomore level combinatorics problem. But to find generalized formula, that's more like junior, senior level mathematics major problem. Okay, I don't have any mathematics degree. Okay, I have very superficial knowledge about group theory, tensor analysis, and I don't know too much about I know basics of linear algebra, probability, statistics. Okay, uh, abstract algebra, topology, very basic understanding of roughly what they are, right? But I'm not. I did not even minor in mathematics. Okay, I just took some classes. That's all. I'm amateur mathematician. Okay, so I didn't major in mathematics. I didn't even minor in mathematics. Okay, so but I learned enough mathematics to do mathematics on my own as a hobby. Right. So okay, let's take 5 minutes or 10 minutes. Okay, so I'm still trying to look for that moose pile that I saw it, but because I want to pick them up somewhere in the left hand side in my backyard. Okay, somewhere there, but haven't found it yet. Yeah, I'm kind of being anal about it. You know, if I don't see it, then what's the problem, right? Yeah, but I know it's there. Okay, just want to find it. So give me like 10 minutes, okay? Yeah, so I need some vocal rest. So, ah, good. All right, let's take a break. Okay. Okay. we are back, and I found them. All right, the moose pile, along with other animal like neighborhood dogs, fishes. Yeah, I found more of them. So next break, I'm gonna pick my latex glove, latex glove, latex joke. Okay, very geeky joke. Latex glove and plastic bag, and I'm gonna pick them during the next break. Okay, so okay, we are ready. So let's go ahead, grab a whiteboard, and express this. Okay, so formula. All right, so yeah, that's more advanced stuff. Okay, because it involves generalization and yeah, we'll do it. All right, we'll erase this guy. We don't need this. We know what this is. Uh, this black pants, man. That's such a product defect. So disappointing. I just bought it, you know. You know, package like 5 of them comes. Only one of them is good, okay? No matter what brand they are. How disappointing. Oh well. Okay. Let me check with my friends, okay? I just want to make sure they're okay. Okay. So, uh, okay. Let me put the other whiteboard where I can see it. My feet are kind of blocking the view. So, all right, generalization. How exciting, right? That's the fun part. Abstraction to come up with a formula for it after we have done all the legwork, making all these examples with numbers. Now we're gonna convert them into letters to make a formula for it. We found a pattern, right? Yeah, so this is the fun part, more metaphysical part, more brainy part, as opposed to brawn. This is fun part. Well, yeah, they're both fun, but this is very exciting part. Abstraction, common formulation, you know. Yeah, that's fun part. Proof, we're not gonna prove it. Not here, not now, okay? Because division of labor, okay? We did enough work finding the formula, okay? And we'll verify it. Maybe we are not going to verify it, okay? So let somebody else do it, okay? Or I'll let you do it, all right? So don't have time, all right? So what can I say? I mean, we don't have to do all the work. Division of labor. Let some other people do it, okay? So when it comes to proof and correction and yeah. You okay? So how was your day? Happy Thursday. Tomorrow's Friday. Yeah. Hopefully, I'm keeping you a good company. Hmm? So President Trump, he's trying to open the economy as soon as possible, and I have to agree with him. Right? Yeah, I do. Uh, but one thing he's missing is that one thing everybody's missing is that, yeah, diet, exercise. Okay, that's what helps you strengthen your immune system. Okay, that's what's gonna prevent coronavirus. Okay, diet and exercise. All right. Okay. Let's do step by step. Okay. So this is a good pen. Step by step. Yeah. Let's not generalize too fast. Let's generalize slowly. Right. So we have that. And first category, we just copy it down, okay? Just express this guy with product of one number. Okay. Right? How many ways are there? Well, out of five, you pick five. Okay? Now, second categorization. How many ways are there to express this guy out of two numbers product? Okay, so yeah, you have two times blah blah blah. Okay, that's let me grab another color because we need at least two colors. Okay, so I pick green, right? First subcategory, second subcategory. You pick two numbers, two primes, okay? Blah blah blah, right? Okay. Let's just enumerate the possibilities, okay, and then we'll come up with a nice formula for it, okay? So three numbers. Okay. You pick one number, you pick another one number, and then the rest. Right? That's the first category. Is this rose leaves? Which one is rose and which one is willow leaves? difficult to tell because they're so young, leaves, so difficult to tell. I think this is rules. It is, yeah. Okay, let me check with my friends, okay? Give me 1 second. Is this some kind of spam? Hmm. Okay, I guess somebody got my credit card somehow. Ah, somebody. I guess somebody got a hold of my credit card, and so they have to cancel my credit card, and I have to get a brand new credit card. Somebody tried to use my credit card. Okay, well, whatever. Yeah, I'll take care of that later. All right. We gotta do mathematics. Okay. I got enough cash. I got enough food in my refrigerator. Okay, so yeah, I'll take care of that later. Yeah, all these people, identity theft, whatnot, right? Yeah, I go to the bank tomorrow and get a new car, whatnot. Yeah, because banks they have very good software to detect all these suspicious transactions, so they let me know when it happens. So was it you? I said no, it wasn't me because yeah, they have very sophisticated like artificial intelligence software, so they detect it when somebody steal stuff. Okay, let's take 5 minutes break. Okay. All right. Hello. Okay, let's stop and restart. Okay, we'll get back in like 10 minutes. Thank you. See you soon.